Here we go. We're going to start our discussion of these various type of angles that you're going to see. Okay, including what we call adjacent angles, vertical angles, complementary angles, and supplementary angles. So some building on some vocabulary with different types of angles. Okay, so vertical angles come in pairs. Okay, they're formed by intersecting lines or segments or rays. Okay, in this arrangement. Okay, they're what we might call diagonally across from each other. So we've got vertical angles 1 and 3 rather, 2 and 4. Okay, 1 and 3 are vertical, 1 is equal to 3. Okay, 2 and 4 are vertical, 2 is equal to 4. Okay, so vertical angles can be concluded to be equal, and we'll have some problems in which you have, well, all I have to do is give you one angle and the other three can be found, okay? Or I give you one angle and another angle in terms of x, and you can solve for x. We'll see that coming out next in a couple slides, okay? Adjacent angles are two angles in the same plane, okay, to begin with, two angles in the same plane. So they say are coplanar with a common side, a common vertex, and no common interior points. So here we are illustrating what two adjacent angles might look like. And of course, as you can see with the two adjacent angles, we can write the angle addition postulate. They share, okay, the common vertex here, the common ray, okay, and they all are within the same plane. Okay, here are adjacent supplementary angles. Adjacent supplementary angles. Again, two angles in the same plane with a common vertex and common rays. Okay, and as we said, adjacent angles affords us to write the angle addition postulate. Okay. Next, we have supplementary angles. Two angles whose measures sum to 180. So here's an example of two adjacent supplementary angles. Here's an example of two non-adjacent supplementary angles. So there's no restriction stating we need to be adjacent to be supplementary. As long as we have two adding the 180, we've got supplementary. Adjacent supplementary, non-adjacent supplementary. And again, angle addition applies to supplementary angles, but more specifically, the sum of the two angles is always going to equal 180 whenever we're talking about supplementary, okay? So again, angle addition will apply, more specifically apply where we can add up the angles to 180, okay? Complementary angles, two angles whose sum is 90, okay? A 90-degree angle is always indicated by a box here, okay? So even if it doesn't tell you necessarily that the angle is 90, if there's a box at the vertex, that will assure you that you're talking about 90 degrees at that box, okay? And if the two angles that are adding up to 90 are what we call complementary. These are complementary and adjacent, okay? These are complementary and not adjacent, okay? So again, like supplementary, complementary can be either adjacent or non-adjacent, but they must add up to 90 degrees, okay? Again, we have the angle addition postulate always applying, but more specifically, we have the sum of the two angles with the angle addition always equaling 90. Just as with supplementary angles, we have the sum of the two angles always equaling 180. I'm going to look at a few examples. Okay, here we are having a couple things going on. Okay, we do have both supplementary and vertical. Okay, whenever you see two angles that are adjacent and their opposing rays form a straight line, then we can safely assume that they are supplementary. So we do have supplementaries with 1 and 2, 2 and 3, 3 and 4, and 4 and 1. So, and we have verticals with 1 and 3 and 2 and 4. Here's an example I was alluding to earlier. If I know one angle, then I effectively know the other three. Okay, so given angle 1 is 35, angle 1 and 2 are supplements, okay, and therefore angles 1 and 2 add to 180. Given that angle 1 is said to be 35 and the other is unknown for the time being, we'll call it x. 35 plus x equals 180, which we can solve for x equaling 145, that being angle 2, okay? From there, angle 3 is vertical to angle 1, and vertical angles are congruent, so therefore angle 3 is likewise 35, okay? Angle 4 is both supplementary to angle 3, but it's also vertical to angle 2. Either way we look at it, we get 145 degrees for angle 4, okay? Here's another problem of an algebraic variety. Determine the value of x in the diagram shown, okay? We can clearly see that the angles are vertical angles, and we had stated earlier vertical angles were congruent. Therefore, we can and should set up this equation, which we can easily solve for x and show that x is equal to 15. Should we want to find the actual value of that angle, we can easily do so. X equaling 15 implies the angle here is 25. Likewise, this one put in for 15 will give us 60 minus 35, which is also 25. Okay. Here we have two angles that are adjacent and complementary. We of course know they're complementary because they have the box there indicating a right angle is formed between the two of them. Our angle addition postulate will tell us that these two angles sum up to 90 degrees. So we substitute those algebraic values back in, and giving us an equation 4x plus 5 plus 3x plus 8 equals 90. Therefore, simplifying by adding like terms, 4x and 3x is 7x, 5 and 8 is 13. We get this 7x plus 13 equals 90. We subtract 13, 7x equals 77, x equals 11. Should we want to come back and find the measure of each angle now, we can easily go back to the algebraic expression and put in the value of 11 for x, which would find for us that the one angle 4x plus 5 is now 4 times 11 plus 5, or 49 degrees, and the other angle is 3x plus 8, with x being 11 now, we find that that is 41 degrees, okay? So we'll have some examples like that that we'll be working on in class tomorrow, okay? Review these and make sure that you know all the terms, the vocabulary, adjacent, supplementary, complementary, and vertical angles, and what angle addition postulate you can write for each of those. Okay, so that'll do it for now.